Fine. So this is a hearing aid, right? The behind the ear hearing aid, because it remains behind the ear. Tube will come and fix here. Will this hearing aid fit everybody?
No.
Yes, no. Why? Because people with different types of hearing loss will be requiring different types of hearing aids, depending upon the configuration. How do you know about it? You know it from a audiogram. So the audiogram, right ear red, left ear blue, and it will be having a pattern, based upon which we decide whether amplification is needed or not. Me talking to you people would be falling somewhere in the speech banana. So this person whose hearing is below the speech banana naturally will not be hearing it. So he needs to have this particular red and blue going up till here, so that up till the speech banana, so that he would be hearing. So how do we know that? We take up a hearing aid. Fine. So nowadays behind the ear hearing aids are in vogue. In government, under the ADIPS scheme, we distribute it free of cost also to the people who have a income criteria. Correct? Now, do hearing aids look different or they look similar? These behind the ear hearing aids, will they look similar or different? Similar. So how do you know which hearing aids gives what amplification? It is based upon the specification. So each hearing aid would be coming with a specification booklet like this, and they would be saying this is the amplification which the hearing aid is giving. So based upon this amplification across the frequencies, you say this hearing aid would be suitable for a particular type of a hearing loss. Correct? So they give this to us and send it to us. Now not necessarily each hearing aid would be giving exactly that amplification. So we have to test it. So to test it, there is a different setup, and this particular setup is known as what? Electroacoustic measurements. Okay, electroacoustic measurements means both electrical and acoustic measurements are being done. Okay. By basic principle, a hearing aid does what? It
amplifies the signal.
Correct. It amplifies the signal. It doesn't amplify the sound per se. When sound goes in, electric signals are created. These electric signals are amplified, and then they are again refed to the person. Okay. So to see whether the promise which this hearing aid is doing, whether it is giving that amplification or not, we take this particular setup in which we have a box. We fit up the hearing aid to a 2cc coupler which simulates our ear, and then there is a loudspeaker. There is a reference mic also, and this box is known as what?
Hit box.
Okay, it's known as the hit box. So I have closed it now, and once I have closed it, I go into this and give a sound. So as you saw, we have a series of frequencies and a series of intensities. So these series of frequencies and intensities should be produced in the mic, in the speaker which is there inside the hit box, and we can hear it, and the output of the hearing aid is measured. Okay, I'll start the test by clicking this. Just hearing instruments. Okay. So you could hear a sound between 100 Hz to how much? 10 kilohertz. So the audiogram measures usually between 250 Hz to 8 kilohertz, because our speech spectrum is in that range, right? This entire thing is done, and then the output comes out. So you look into the promise which the hearing instrument does match the output in terms of OSPL 90, OSPL high frequency average, full on gain, etc., etc. Quite a number of parameters, and if it matches, then we say, okay, this hearing aid would be suiting this particular client, or this hearing aid would be suiting this particular client. Correct? So to measure out whether the hearing aid is working faithfully or not, we have this instrument which is known as the electroacoustic measurement